Hello, this is video 3.1, Solving Systems of Equations. Our concepts in this section are we're going to solve systems of linear equations graphically, and we're also going to solve them algebraically. So let's go first into the summary, the different ways of solving systems. These are all the different ways listed. You can make a table, which the book shows us, but we're not going to entertain that because that's like looking for a needle in the haystack, and it's a waste of our time, and it's really not something we're going to use later on, only when they give us perfect little simple problems. So we're just going to ignore that. We can graph them. We can use substitution or elimination methods, and in elimination we'll use addition of adding the two equations and subtraction and multiplying as well. So basically we have three different ways we're going to learn: graphing, substitution, and elimination. So let's look at our vocabulary. So our first word is break-even point. If we go to our book, they give us an example here. Libby borrowed $450 to start a lawn mowing business. She charges $35 per lawn and incurs $8 in operating costs per lawn. A system equation can be used to determine the break-even point. So the break-even point in this example would be a point at which the income equals costs. So break-even point is just a point at which two quantities are equal. Okay. So let's look at example 2. Like I said, we're going to skip making a table because it's really not realistic. So we want to solve this by graphing. So we have two equations, 2x minus 1 minus y equals -1, 2y plus 5x equal -16. Well, the first thing we have to do in order to solve these two equations, we have to put them in y equals mx plus b form. So we're going to we've spent a lot of times. It's an Algebra 1 TEK, so we should be familiar with how to do this. So we have -y equals -2x minus 1. Divide everything by -1. So I'm not going to sit here and spend a lot of time on how to solve equations. If you need help with that, get with me during class and any other time, and we can go over this. The next one is 2y plus 5x equal -16. We're going to get 2y equal -5x minus 16, and y equals -5/2x minus 8. So here are our two equations. If we graph them, so we're going to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5. 2, 3, 4, 5. So we're going to go to 1. We're going to go up 2 over 1, up 2 over 1, down 2 over 1. And you would use graph paper for graphing systems when you're not using algebraic, when you're using the graphing method. So we're going to go to -8, 3, 4, 5, 6, 7, 8, and we're going to go up 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, 1, 2. As you can see, because I didn't do this on the graph, it's hard to see where algebraically they cross. So let's look at the book so you can actually see it. This is why graphing is also not a good method, but sometimes it is if they give us perfect numbers. So here is the graph, and you can see they intersect here at -2, -3. That is the intersection at that point, so it's -2, -3. And how we would verify that that answer is correct, we would put these into both the equations. So remember, this is x and this is y, so we just substitute -3 equals 2 times -2 plus 1. Does -3 equal -3? Yes, it does. So that one works. Let's make sure this one works. So -3 equals -5/2 times -2 over 1 minus 8. So this cancels. This becomes a positive, and -3 equals -3, and that works. So this is a solution. Now, we could have gotten a solution, and it could make one equation true, but the other one false. If that happens, then we did some bad math somewhere. So you have to check your answer in both solutions. All right, so pause the video and do guided practice 2A and 2B. All right, so let's go to our next vocabulary word. So there are ways of classifying systems of equation. And they are by being consistent, inconsistent, independent, or dependent. Okay, so these are ways that we can classify them. If they are consistent, that means they have at least one solution. If they're inconsistent, they have no solution. So they're either going to be consistent or inconsistent. One or more solutions or no solutions. Independent says it has exactly one solution. Not infinite, not two, not three, exactly one. Dependent says it has infinite solutions. Okay, so let's look at our example from here. Let's look at our chart right here. So you'll notice here you have two intersecting lines, so there's exactly one solution. So this would be considered consistent and independent. Here, they're the same lines. You can't see it, but they're just the same lines, so they're on top of each other, so they have infinite solution. So we say this is consistent and dependent. When they're parallel lines and they have no solution, we just say they're inconsistent. We don't say they're independent or dependent. They're obviously not dependent upon each other. You could technically say they're independent, but we don't use that for parallel lines. If we have parallel lines, there's no solution, and that means they are inconsistent. Okay, so let's look at example with that on there. So that would be example 3. It says graph each system of equation and describe them as consistent or independent. So we have to first put them in what? Y equals mx plus b form. So I did it already, and I'm not going to do the algebra. So you get y equals negative 4/3 x plus 8, and you get y equals 3/5 x plus 6. So let's graph these. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go 1, 2, 3, 4, 1, 2, 3, 4, 5. So we're going to go 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. And we're going to go down 4, 2, 3, 4 over 1, 4 and over 1, 2, 3. Okay, so we just need 2 points at this point because we're not finding the exact solutions. We're just determining what type of classification, what kind of system it is. 3, 4, 5, 6. And we're going to go down 1, 2, 3 and over 1, 2, 3, 4, 5. And you see that these two lines cross at some point here. So there's exactly one solution. So this is going to be consistent and independent. Let's look at the second one. So if we solved B, example 3B, we're going to get y equals 2/5 x plus 2 and y equals 2/5 x plus 2. What do we know? So we have 2, okay, and we're going to go 1, 2, 1, 2, 3, 4, 5. Okay, and we notice that they're the exact same line. So they're on top of each other. So they're going to have infinite solutions because they have the same slope and the same y-intercept. Therefore, we say that these are consistent because they have one or more solutions, and they're dependent because they're dependent upon each other. So now pause the video and go and straight and do guided practice 3A and 3B. let's look at our next vocabulary. Our next vocabulary is going to be a substitution method. That is just a method of solving systems algebraically by solving one of the equations for one variable and then substituting it into the other. So let's look at an example on how we would do that. And sometimes we actually use real-world problems in systems because we're trying to find a break-even point. And this is getting us ready for linear programming. So it's just basically systems. When we get there, most students get afraid of it and they're like, it's just systems. All right. So it says Alejandro has a computer support business. He estimates that the cost to run his business is represented by y equals 48x plus 500, where x is the number of customers. He also estimates his income by y equals 65x minus 145. So how many customers will Alejandro need in order to break even? So we want to know, what will his profit be if he has 60 customers? So the first thing we want to do is find out, when will he break even? How many customers does he have to break exactly even? So we take those two equations, y equals 65x minus 145, and y equals 48x plus 500. Now, we just take one of the equations and solve for either y or x. It does not matter. They're both solved for y, so we can just take these equations, substitute that in for y. So we can take these and set them equal to just, we have 65x minus 145 equals 48x plus 50. If we do the algebra and solve for x, we're going to get x equals 37.9. So now this represents the number of customers. So we can't have 0.9 of a customer. So Alejandro needs to break, if we do 37, we round down to 37, that's not going to break even. It's going to be slightly short of it. So he needs to have at least 38. He has to have 38 customers to break even. Now, they want us to know, what will his profit be at 60 customers? So we have to do f of 60 here and f of 60 here. Remember, because the first one is his income, and the second one is his cost, and profit's going to be income minus cost. So we put f of 60 here, we get 3,755. We put it in here, we get 3380. And then we find the difference of the two. So his profit, because his income is more, he has a profit of $375 when he has 60 customers. Okay, pause the video and do guided practice 4A, 4B, and 4C using the substitution method. Our next vocabulary we're going to use is going to be called elimination. That's just another method of solving systems of equations. And we're going to use addition and subtraction of the two equations to eliminate one variable, and then we'll take it and substitute it back into the other. So the method for doing this elimination, you can go by their steps. First, we multiply one or both the equations. This sounds confusing, but until you actually do it, then it's not hard. And two equations contain the opposite terms. Add the equations, which will eliminate one variable, then solve the equation, and then substitute it back in. So let's look at example 5. It says, use the elimination method to solve the system equation. Now what you want to do is you want to have your x's and y's put in basically standard form, but it doesn't have to have whole numbers. It can have fractions or decimals, okay? So if we did substitution here, if we solve for x or y equation, A or B, does not matter, we would get fractions, which is okay, but you have to be really, really good at fractions and know and deal with fractions. So let's use elimination. So you want to put your x's lined up, your y's lined up, and your constants lined up. So kind of in standard form. So then we look at the coefficients. We want to have the same coefficient. So we want to have kind of like the least common denominator, the least common multiple of coefficients. So I have 5 and 8 of 3 and 3. So you want to have the same coefficients. And you want them to be opposites. I don't have any like that, but I do have the same ones here. So it will be easy for me to change an equation. I'm just using the multiplication property of equation and changing one of these 3y's to a negative. So let's start by writing the equations, and they are 5x plus 3y equals negative 19. Then we're going to have 8x plus 3y equals negative 25. It doesn't matter which one I choose. I'm going to choose this one, and I'm going to multiply it by negative 1, the entire equation. So remember, I'm not changing this, so I'm just going to rewrite this. Do not try to do it all in one step. Rewrite it. Take the time. I multiply this entire equation by negative 1. I'm using the multiplication property of equations. It says I can do that, and I'm not changing the equation. I'm just changing its look. So this becomes negative 8x minus 3y equals 25. You must distribute all the way through. Now I'm going to add the two equations together. These are opposites, so that equals 0. These equal negative 3x, and this equals 6. Then I solve for x. Divide by negative 3. Divide by negative 3. I get x equal negative 2. Now I'm going to put it back into one of the original equations. It doesn't matter which one. 2 for x, so I can solve for y. So I have negative 10, so I'm going to add 10 to both sides. So I get y equal negative 9. Divide by 3, and I get y equal negative 3. So remember, the break-even point is a coordinate xy, so my solution is negative 2, comma negative 3 in coordinate form. And I do want to check it to make sure that I didn't make any bad math errors, so I'm going to put it in the second equation. So 8 times negative 3 plus 3 times negative 2 should give me negative 25. So does 9, oops, this is 8. Does negative 24 minus 6 equal negative 25? And I must have done something wrong, or wrote this down wrong. So 8 times, oh, this is negative 2. Whoops. So 8 times negative 2 plus 3 times negative 3 equal negative 25. So negative 16 minus 9 equal negative 25, and negative 25 equal negative 25. And I did it right, so this is my solution. So stop the video now. Oh, no, we got one more. Okay, pause the video and do the 3 guided practice, 5A, 5B, and 5C. Okay, the last thing we're going to do is we're going to talk about special cases. Now, when you're solving an equation, whether it's substitution or elimination, as you're solving them, you might get something like 0 equals 0, 10 equals 10. These are true statements. Or you might get a false statement that might say something like 0 equals 4, 1 equals, negative 1 equals 10. It's a false statement. Your variables somehow get eliminated, get all from both sides, and you end up with two numbers equal each other. You'll either get a true statement or a false statement. If you get a true statement, then your solution is going to be infinite solution. Sorry. That means you're going to have infinite solutions there. If you get a false statement, then there's no solution. And how you can check that is you can either put it in your calculator, and you'll see no solution. You're going to have parallel lines. So you can take the equation, solve for y, and you'll see that you have parallel lines. If you solve for y, you'll either get that they're parallel, same slopes, different y-intercepts, or they're the exact same the equations. For an infinite, they will be the same equations. If you solve for y, and yes, when you solve for y, you'll get the exact same equations. That means they're infinite, the same line, parallel lines, no solutions. So let's look at the last example. That would be example 6. All right, so solve a system of equations. Is it A, B, C, or D? So let's solve it. So let's do 5x plus 3y. So you have to know both methods because you will be asked to do both methods. You'll also be given the opportunity to choose the method of your choice. Doesn't matter. Sometimes it's better to do substitution. Sometimes it's better to do elimination. Just depends. All right, so I have no two coefficients that are the same or opposite, same and opposite. So these two numbers are smaller than these two numbers. So I need to have the least common multiple or coefficient of 9. So I need to multiply this by -3 because I need them to also be opposite. Okay, so I'm going to distribute through, so -15x minus 9y equals -156. Then I have 15x plus 19y equals 54. So when I go to solve this, this cancels out to 0 because these are opposite when I add the I'm adding the equations together, whatever signs they are. So I have 0 equals -102. This is a false statement. I have no more variables, so that tells me the lines are parallel and there's no solution. I can check these by solving for y for both of these, and I'll see they'll have the same slope but different y-intercepts. So stop the video, do attempt guided practice 6, and we'll see you in class.